Yeah, we are talking about logarithmic function. Log x differentiated value will always gives you 1 by of that particular value. So here our y itself log x. So we need to write differentiation of log x as d by dx of log x. D by dx of log x is 1 by x.
1 by.
Is it right?
Yes, sir.
Okay. So the remaining you are already known very well. Algebraic function, parametric function, double differentiation, inverse trigonometric, hyperbolic function. Algebraic function nothing but x square plus 5 plus some values you can going to put. You know that differentiation of algebraic function can going to use all our differentiation rules. We're going to discuss the differentiation rules also, each one now. So algebraic function normally going to have like this: x square plus 5. You have to put this one as y equals to, once you call it as equation, it must have LHS and RHS. If you call it as expression, only one term, only one, it may be LHS or RHS term, need not to be have the both sides. That is the main difference between equation and expression. So when you want to that algebraic function, both should be there. And you can give the another example. Can you tell me the another example on algebraic function?
5x square plus 4x plus 6.
Very good. 5x square plus 4x plus 6. Is the one. If I differentiate that, you know that when you going to have these terms are called coefficients or constants. X is called it as variable, right? When you
Yes,
want
sir.
to differentiate, you need to keep that coefficient outside and then differentiate only this x square by using power rule. And also here you have to keep this one outside and differentiate this x only. Then differentiation of only constants gives you 0. The reason behind why it is happening, if you're going to differentiate only constant, why it becomes 0? If it is maybe your question, you know that if I'm going to write graph for x is equal to, sorry, y is equal to 6, y is equal to 6, if I'm going to write this graph, how can I going to write? There is no variation at all in the x, so it is the indication at all points of x y value is 6, right? It means this is the graph. Do you agree for this?
Yes, sir.
So when you differentiate this, what happened? We are going to differentiate to find the slope of the quantity. If there is no slope means amount of bending. There is no bending at all. So differentiation of constant always leads you to 0.
0.
Do you understand how we are
Yes,
going
sir.
to write differentiation of constant is 0? Because it doesn't bend at all. The main purpose of differentiation is finding the slope and going to find the point of contact to the tangent. Fine?
Yes, sir.
Okay. Can we make this all clear markups? Can
I
you?
should do.
No, I will going to do that if you are clear with this.
Okay.
Yes. Now let me go to the topic by name, rules of differentiation. Totally how many rules are there? Don't worry, if it is wrong also, I'm not going to demotivate you. I will help you with that. What you
4.
remember? Okay. Which are those?
Uh,
Just try to remember it. Long back we are covered that. So what I am given the revision class now. First is power rule.
uh,
Okay. What is the next one? Addition or subtraction?
multi
Yeah. Next is we're going to call it as product. That multiplication
product.
only product we're going to call. I just write A R S here. Okay, it is understood to
Yes.
you. What must be the next?
Product.
Product, that is also called multiple, or we going to call that one as UV rule also, not Yuvraj Singh rule, that is UV rule. And fourth one is
Log.
quotient, numerator by denominator, differentiation rule,
Yes, sir.
quotient rule. Still rules are there. Chain rule,
Chain rule.
most important. Okay, in all the problems you can going to use that. Then what about what telling about logarithmic, parametric?
Logic.
They are not considered for rule, they are forms. Okay, they are going to call it as another types of differentiation. These are the basic rules. We are going to use these basic rules in logarithmic rule. The function, different types of function, logarithmic, exponential, trigonometric, algebraic, hyperbolic, they are different functions. For that different function to differentiate, we use these rules. Don't get mixed up with different types of function and rules. These rules can be implemented to solve those different trigonometric different functions normally. Okay, so
Yes,
you
sir.
already seen in the previous slides, previous workings, all totally we have trigonometric, algebraic, logarithmic, exponential, hyperbolic, inverse trigonometric, parametric.
Double differentiation.
Parametric double differentiation is differentiating the given function again, that's all, two
Oh,
times. Okay, we are, when you go to the higher studies, nth type, n time of differentiation also come, engineering or degree at that time. Okay,
mm. Yes, sir.
so these are all the fundamentals. Wherever you go, this will be the fundamental. So power rule, you know that power rule can be going to given differentiation of x to the power n is equal to n into x to the power n minus 1.
Yes, sir.
Okay, since we are already discussed, I am not writing that, I make you fastly revising. Okay, the next is it required to you to write it, or you able to understand?
I'll understand.
Very good. Then addition or subtraction rule will going to give you, that will be if you separated the given terms by plus or minus symbol between the expression of algebra or trigonometry, exponential, any function, that will remain same, and differentiating the terms separately and keeping that in that particular position. That is about addition or subtraction rule. When you come to the product rule, that is in the form of UV rule, U dot V, if you differentiate it, that gives you U dash V plus V dash U, means differentiate the first function, keep the second as a constant with multiple, plus differentiate the second and keep the first function as multiple. Is it clear?
Yes, sir.
Yes. Next, quotient rule will tells you, you have to take the numerator and denominator, u by v rule it is. When you're going to do that, you will have to keep the denominator square. I will going to write for your clarification here, it requires. This is the form you're going to get here. If you're going to use this d by dx here to this, what happened? It gives you denominator always v square, right?
Yes, sir.
And then u dash v
Mm.
means differentiating the numerator once and then v
V
dash
dash
u.
U.
That will be the scenario. Understood?
Yes, sir.
And chain rule is going to be applicable when the function inside the function is there. F of x into g of x, that will be product rule. If you're
Yes, sir.
going to use f of g of x, function inside one function, at that
Mm.
scenario you have to differentiate the outside function and then you have to differentiate the inside function. Until you're going to get one, you have to differentiate by putting multiple symbols. For example, sine of x square, differentiation of sine of x square is cos x square times 2x. We are
Yes, sir.
differentiating the sign of x square, that sign we are differentiating first and then we are going to put multiple sign and then we going to differentiate the x square, that gives you 2x.
Two
If you
X.
again if you differentiate that x, that